This example asks us to use the closed interval method to find the absolute extremes on this closed interval from x equals the opposite of pi over 4 up to x equals pi over 4. To understand this problem, let's make sure we understand what our interval is. We're going from negative pi over 4 on a unit circle up to pi over 4. So the interval we're concerned with is from negative pi over 4 up to pi over 4. It looks like this on the unit circle. When we look at the secant, the other thing we need to notice is that the secant of x is 1 over cosine of x, right? Because the secant and cosine are inverse relations to one another. And then the last thing I want to look at is the derivative. Notice that if I wanted to do the derivative of secant, I'd get secant tangent. So those are a couple of things that you want to note before we even start. Let me show you how I worked this out. To start with, up here in the top right, you'll see that I was doing the derivative. Given g of x is secant of x, if you say to yourself secant, tangent, then you'd get that the derivative of secant with respect to x is equal to the secant x times tangent x. So the derivative of negative 2 secant x, the derivative of f of x, is going to be negative 2 times secant x tangent x. You could think of that when we rewrite secant as 1 over cosine and tangent as sine over cosine, you could think of that as negative 2 times the reciprocal of cosine times sine over cosine. So the question when we're trying to find where, so the location, where is there an absolute extreme? The extreme is going to happen when the derivative is 0 or when the derivative is undefined. So let's start by finding when is this f prime of x equal to 0? Well, this, let me highlight what I'm referring to. When I say this, this expression, negative 2 times 1 over cosine times sine over cosine, is going to be equal to 0 when this numerator, sine, is 0. A fraction is equal to 0 when the numerator is 0. So that's when sine of x is 0. This happens on our unit circle at 0, right? That y value is 0 when x is 0. So the sine of 0 equals 0, and we could table that and say that later on we're going to find f prime of 0. I'm going to go ahead and do that right now because I know that an extreme could happen at f of 0. So if I replace the x with 0, I get negative 2 times the secant of 0. The secant of 0, using my unit circle, will be 1 over cosine of 0, which is 1. So negative 2 times 1 over 1 is equivalent to negative 2 times 1, or just negative 2. So f of 0 is equal to negative 2. That's a possible extreme. Let's continue our investigation of finding extremes by looking at where is this first derivative undefined. Because the absolute extreme, which is what we're looking for, happens either when the derivative is 0 or when it's undefined. We need to look, we already did the equal to 0. Now we'll look at where is it undefined. It's undefined when the denominator, the cosine of x, is 0. And on our interval that goes from negative pi over 4 up to pi over 4. In this interval, we never get a cosine of 0 because the cosine equals 0 at negative pi over 2 and pi over 2. So this plus or minus pi over 2 is not on our interval. So there's nowhere on our interval where the secant times tangent is undefined. So we found our critical number. It's only one, and that critical number is x equals 0. What we would do next is find the value of the function at each of those critical numbers. So we only had one of them, 0. And then at the end points, the opposite of pi over 4 and pi over 4. The critical number is 0 because that's where the derivative was equal to 0. And the end points are negative pi over 4 and pi over 4. When I find the value of the function, and that's going back here to the original function, when I find the value of the function at 0, I got negative 2. Let me highlight those to make sure you're with me there. F of 0 is negative 2. And then I can find f of negative pi over 4 and f of pi over 4, which, by the way, are equivalent. They're both negative 2 square root of 2, because it's negative 2 times the secant of pi over 4, or the secant of negative pi over 4. The cosine is square root of 2 over 2, so the secant is square root of 2 under 2. And when I simplify that, I get negative 2 square root of 2. So it looks like we have, let me turn the page here so we can see it all. It looks like we have a minimum. The lowest point is negative 2 square root of 2 at negative pi over 4 and pi over 4. And the maximum value of the function is negative 2, and that happens when x was 0. Let me write that in here to make sure that didn't show up in the... It didn't show up in the picture there. But we have a maximum of negative 2 at x equals 0. Well, I hope that this short video helps you better understand this example. Please reach out to me if you need further assistance with it.